In the last video, we saw how we can store our data in so-called arrays. We've added them to arrays and we've created multiple of them. We've looked into data types of arrays. And in this video, we'll have a look at how we're going to utilize this in more detail by going through an array and looking at the individual fields in a so-called loop several times. And there's what we have in programming languages, control structures, where you control the flow of the program. And in this case, you would want to have some type of loop. So there's a loop, give each player one random card. And if we give the players the random cards, it's already shuffled. So we don't need to form a shuffled deck. The cards will be shuffled already. And what we do for a loop is there's different types of loops. Let's see the different types of loops. Julia loops. Control flow in the Julia documentation. There is different ways of doing this. There is the easiest or the most frequent way you see something is, let's go to the loops. These are control structures. We'll see them in a while as well. Short circuit evaluation, we'll see this as well. Repeated evaluations. There is the so-called while loop. Let's zoom in and you will see this. While I is smaller than 3, println I and global I plus 1. Let's see if I do this here down here. You will see I is not defined. Okay, let's see. I forgot the first one. And now I could, yeah, it basically says 0, 1, 2, 3. And so while the I value is smaller than 3, it will print the I value and then increase the I value. We have this global I in here because once we're inside of a nested structure, and this is a loop, so it's a nested structure, so we were in the loop, the variable reference refers to variables inside of this loop. And if there's an I outside and an I inside, it will use the one inside. And we don't want the one inside. We want the one on the level of the loop. And so for this case, this one uses global here. The while loop doesn't seem to be most ideal here in this case. And the one that I think is going to be better here is the for loop. And the idea here is, let's first see what the for loop does. So let's say for I in 1, 2, 3, and we do println I, print line. Let's do this, and it does 1, 2, 3. What does this here mean? 1, 2, 3, 1 colon 3. This is basically a list that has not been expanded. It's a 3-element vector. If you go into the answer here, let's see if we can. The answer is a unit range with 3 elements. And let's do this more meaningful. List range is I'm just using maybe this. A list range 1 to 10 is the numbers from 1 to 10. So I can address the individual numbers here by going, for example, the 5th element in this range is 5. And the 5th element, the 3rd element is 3. And this seems kind of unnecessary, but if we start from 451 to 710, then it's not as clear what the 3rd element is. So this is a tool to create a list of elements that are, one after another. So basically this is just 1, 2, and 3. That's what it says. And what we do now is we use I, the iterator, to go through these 3 elements, 1, 2, and 3. And for each of these positions that they can take, I will do what is between this for and end. In this case, print it. We could add them as well. So we could do something like A equals 0, and we could do global A equals A plus I. And this will now, in the first run, it's A is 0, but I is 1, so it does 1. In the next round, A is 1 and I is 2. Let's see what's the outcome of this. And the end result of A in this case would be 6. 1 plus 2 plus 3 is 6. That's not what we want. So what we want is we want the iterator to go, we want to do half as many rounds as we have cards. So it would go from the first round 2, and then we can write this in parentheses, cards count divided by 2, end. And let's just see if this is correct. We print the I, and we have 1.0, 2.0. So we do 2 rounds, but interestingly, we have floating point values here. And the reason for that is if you divide by a number, the result could possibly be a float. And in this case, the result is, it could also be an integer, but to be safe, it uses a float. It will work. It will give you the 2 numbers here. But maybe we can design it in a way that we just use the integer division. Let's Julia integer division. What are the mathematical operators? So we have divide, and if we use this sign here, then it's truncated to an integer. We can also do inverse divide. Interesting, didn't know that. How do you do this symbol? I copy it and let's see if that works. That's the thing in Julia, you can write LaTeX code in here and it will work. So for example, if you want to see if is 4 less than 5, then you just type the lesser key, and yeah, that's true, less than 6. But you can also, is it less than or equal 6? That's also true. But this now doesn't look like less or equal, it looks like an arrow to the left. So what you could also do is, if you're familiar with LaTeX, you could write LEQ, which means less or equal. And if you then press the tab key, it will replace it with the LaTeX sign, in this case, the less than or equal, and this will give you a true. You can also do it for testing whether, for example, the number 5, is that in the list of numbers from 3 to 8. That's true. But you could also write in tab, and then you get the element, which is is 5 an element in the set of numbers 3 to 8. And that is also true. That's basically the same operator. Interestingly, this, I don't know what the name of this is. Let's see if it works. Div. So that's div. Interesting. What happens if I write div? That doesn't work. Does it? Maybe that's how it's done. So slash div. Oh yeah, that's how it works. So now I can write print these numbers from 1 to half of the length of all cards, and it goes 1 and 2. Perfect. That's exactly what we wanted. And by going \div and then pressing the tab key, we get this div element. So what do we want to do in each round? So we now have the right amount of rounds. Let's actually say to know what's happening, we will just write round $I. So every round, yeah, we see we have 2 rounds. Nice. And we have these decks of players, and these should be empty in the beginning. So let's call them, they're also a vector of the type car, and they're empty. Deck player 1, deck player 2. We cannot do that anymore because, yeah, we did that already. So let's not do this. But what we want to do now is we want to randomly pick a card from all cards. So let's do random from all cards. And we want to add this to the first player first. So we'll do push, exclamation point, deck player 1. We'll add the random card. But now what will happen if we do this for the second player also gets a card, by the way, obviously, that's what we want. And if we do this now, we'll have to restart everything because we reassigned these global variables with a type, and that's not possible. So let's do it over again. It ran the 2 rounds, and now we should have deck player 1, and that person has, the first car is the BMW X5, the second car he has is the Mini Cooper, and the second player, what's in his deck, he has the Nissan, which is nice, and he has also the BMW X5. That's not possible. You shouldn't have the same card. And the thing is, the random function is not aware of whether it has been used before. Nowhere did we ever say that card has been used. So we should probably remove this card from all cards as well. So it's no longer in the deck of all cards. So we should probably say there is a drawn card, and that is random all cards. And so if we do this once, it will just draw the Mustang card from the stack. And then we should take it from the all cards. So we should have something like remove. I'm not sure if remove is the right one. We'll see. All cards, and we want to remove the drawn card. Does that work? No, there is no remove. An interesting thing is, by the way, the push function, it has the exclamation point because it says the idea behind the exclamation point is it lets you know that it will change one of the variables that you're using. There is also a non-changing version. So if you run push deck player 1, oh no, actually for push that doesn't exist. But for some functions there are two versions of it, one with an exclamation point and one without. The one without the exclamation point will not modify this variable, but it will return a copy of this variable so that you can work on a copy without affecting this one. So we get a list that has this random variable in there, but you do not change the old list. So remove is not the right one. So let's figure out what is the right one. Remove element from vector Julia. How to add, delete, and replace items. Is this the link that I want? I don't know. Maybe, let's see. But we get the first element by first, last, string, pop first. Pop first, pop. Pop gives me the last item. Pop first gives me the first item and removes it. Delete at, we can delete a positional arg, so we can tell it which one to delete, which position to delete. Is there a way to delete elements that are the same? That sounds overly complicated. Keep at, no. We can push to an array. We can, how to get Julia with the numbers in a given range is just collect, okay. Array, replace. That is not what we want. How do we remove an element if we have the element? By value. Delete. Delete is the one that we want. So let's say delete. And let's see if that works. I'm not sure if it does because that was actually the question in there. No, I don't want to. No method matching delete. Okay, that doesn't work. How to remove element 10. From the document delete at, remove the items at the indices given by returned modified. Okay. So what it tells us is we cannot delete an object because it could be the case that this one is not there. It's not in the array. In this case, obviously we draw it from the array, but it could be that we give it a new car. We could delete a new car and it's not in there. So what should it do? The idea of the delete function is then basically you don't tell it what card to delete, but which number card to delete. So in the all cards, we have 4 cards, and in this case, we pick any of them randomly, and we want to delete the one that is identical to the one that we've picked. And that is sometimes, it seems a little bit overcomplicated, but it's actually kind of easy to do depending on the complexity of the data set. Let's see if someone found a better solution. No, they didn't. So the best, some people use the filter. The best answer with 11 likes is the delete at function, and we want the indice delete at. So let's do that, delete at. And we want the idea is to delete all cards dot equal drawn card. So what does this do? Let's run this quickly. All cards dot equal drawn card. No method matching length. That doesn't work. Why would that not work? So I can explain you what they're doing here. So the idea is we go through all the elements of the array, because the dot equal means compare every element. Do something with every element of a list, a vector, or an array. And what the dot here means is what you do to every element is compare whether it's equal to 10. And that is only true for the elements that are 10. And so if I do delete at, this gives me a Boolean array of which of those are equal to 10. So let's do this down here so we're not getting ahead of ourselves. So all cards dot equal a, let's look for the Nissan, which should be the fourth, right? The fourth car. So we should get a 5 element bit vector. No, don't push. We didn't want to push. We just wanted the car. Now we have 5 cars in there. No method matching length of a car. So the thing is, what it does, it looks at equal, and obviously the first equal thing that it does is it's trying to see whether they're the same length. Only if they're the same length they can be the same. But we haven't defined what a length of a car is, and it doesn't really make any sense. So how would we compare this? So this is probably only somewhat useful. We could expect the name to be unique. There shouldn't be different Mustangs or in here. So what we could do is we could see if the name attribute is the same. So let's see, remove struct element from a vector. Maybe let's have a little bit more complex. They have something filter. I don't know if that works. Set difference, that could be interesting. Delete at, find all. But these are all still simple items. So delete an item not with an index. Collections and data structures. Iterator. I have an idea, and that's something how we can make this more simple. So what we do here is we draw a random card, and then we have this this car, and we want to look for that car in the set. But how about we just, normally we don't take the car and look at the car and remove that car from the stack. What we do is we draw a random number of card, like the first or the second or the third, and we will remove that card. And that's quite easily done. So what we do here is, let's do it like this. We first see how many cards are there in the deck. So deck remaining is the length of all cards. And we then, let's remove that. What we want to then do is we want to pick one of those. So what we do is random deck remaining. So what this does, the first thing is here, well, let's just do this first line. This one basically says there's now 5 cards in there. Okay, I don't care. And what this does is it gives me a 5 element. Oh yeah, so this is the number 5, and if I call rand on the number 5, it will give me 5 random numbers between 0 and 1. That's not what I wanted. I wanted a random number between 1 and 5, and I think that's how I get one. Yeah, so this one, if I call this, it gives me a number between 1 and 5, a random number, and this is the index of the card that we're going to give the first player, or the first player, and we will remove it from all cards. So we can do delete at all cards, and we give it the index. Maybe we should keep a copy of it first. So let's call this car is all cards, and we want to get the one at this position, and at the position in an index is with these brackets. So we can get, now I probably removed all the cards, right? Yeah, so this, because I deleted it and ran it 5 times, there's no more cards in there. So what I need to do here is I need to give this to this. I should probably restart and start all over here. Let's just run. I can mark this and then press Shift Enter. It will execute only the stuff that I highlighted. And we now have all cards in the deck. These are the cards that we have. And the deck remaining is 4. We pick a random card, in this case the first. We take the car from that, it's the Mustang. We delete that from all cards, so now all cards is only a 3-element vector, and we can now push that car that we just took to deck player 1. And after that we do the same thing with player 2. So we'll just do that again and do this here and give them this car. So this would be give player 1 a card, and this would be, oops, give player 2 a card. And if we do this correctly, let's start all over again. We get an error. Why do we get an error? Because method, no math. Did I do something wrong here? Wait, where am I? So the deck remaining is the length of all cards. I get an index. We delete the index. We push it to the second player, and we do this twice. So how about we print the remaining deck size? Print deck size is $1, so we know whether it's decreasing in size. Deck remaining. Collection must be non-empty, obviously, so we forgot to add the cards in. We have the decks, and now where is, so round 1 deck size 4, round 2 deck size 2, that worked. Why we did print and not print line, that looks awkward. And now in the second round I is 2, and then no, it worked actually. Did it work? All cards is 0 elements. Oh, it actually worked. So there was, I don't know, was there a mistake? Maybe this wasn't, yeah, this was the mistake, that didn't work. So now we assigned all the cards to the individual players. The decks, we now have deck player 1. This one has 2 cards, and deck player 2. This one has 2 cards, and these will never be the same because when we give it to one, we take it from the list. So we can always go back, and now at the end, we will have, this is round 1, this is round 2, the deck decreases, and in the end we have player 1 has these 2 cards and player 2 has these 2 cards. And these are going to be different because we pick them randomly from the deck remaining. So now we have 2 decks. The decks are a little bit, actually, accidentally, did I? Oh no, I didn't want to do that. Now we need to decide who plays first. And maybe this is a good point in time to think about, and this could be this should be an exercise for you, is, I mean, these lines are the same as these lines. And if we change something, like for example, oh, we printed it here, but we didn't print it here, that's not really a good idea to do, right? We should probably not write the same thing twice if it's the same, because if we change something, we need to change it in 2 locations. And if we forget, then something odd might happen. It's a good practice in programming, if you do something multiple times, is to think about whether you can put that into some type of loop or structure or function, which we haven't talked about yet. So let's say, okay, we should probably do this for the different players, and we should, like, say first player 1, then player 2, then player 1, then player 2. And we do this the way we're doing it right now because we have 2 deck players variables. But what we could also have is we could have a vector of 2, so we will have 2 decks. And in this case, how would we do this? Well, in the all cards we don't need here, we would say this calls decks. And the decks in this case would be an array or a vector of deck player 1 and deck player 2. So this is a 2-element vector of car. Does it make sense? So this has a list of 2 decks. And we could do this also by saying decks. Let's make this the way it is, as a vector of a vector of car, and it's currently empty. So this is an cannot set type for global decks. Yeah, because we already initialized it. And if we do this like this, it will be an empty list, so we'll have no players with no decks. But we're kind of, let's say we have, let's put this in quotation, let's put this into a comment. That's something we can also do, this one as well. This is what we don't need anymore, which we want to replace. We want to have 2 empty decks in there, and we know that an empty deck would be this. So in this empty list, we'll put 2 empty lists. Does that work? If we restart it. Obviously this will error now because we don't have the deck player 1. But do we have a 2-element vector? Yes. The decks is a vector of car with 2 elements. And the first is a vector car. Yeah, we have 2 empty decks. Perfect. That's what we wanted. So in this case, we wanted to give a player a card. And this means we don't push it to deck player 1. We push it to decks 1. So that would be the first player. And obviously the second player is doing the same thing with decks 2. So this will give it to the first player. This will give it to the second player. We could use a variable called j. We started here with I, and we're going to do j now. So we'll do for j in 1 to 2. So we'll just do this twice. And we'll do it once with 1, and we'll do it once with 2. By the way, what I just did is I highlighted some lines, and by pressing Option or the Alt key on the Windows keyboard and up and down, I can move the whole block up and down. So I moved it inside of this for loop. So this is do it, give both players card, and here give 1 player card. And this thing is now, so this we do, this is how many rounds we have, and this is how many players we have. We could now easily switch this up for 3 players by doing this and going here to 3 players. Now we'd have 3 players. Obviously the amount of cards doesn't add up at this point in time, so we'll just go with 2. As an exercise, you could think about how you would change this code to a 3-player set. At a certain point in time, you would have to break when deck remaining is 0. You can no longer give out cards, and you would have to exit this loop. Exiting the loop is, by the way, I call it break. So now, if we do this, we have our empty decks, and if we run all of this, we get an error. IDX rand collection must be non. Oh, we took one already, so it doesn't work anymore. So let's start over again. Close and start. And we see round 1, the deck decreases by 2, round 2, and now the deck is empty, and now we have 2 decks. Deck 1 is, no, it's decks. Decks 1 is Nissan and Mini Cooper, and decks 2 is the Mustang and the BMW. And these will never be the same because we took them from the same array. Who plays first? So we wrote a 2 in here. And if this is 3 players, and this, you should have tried this, you should do the exercise first. Don't try to move this to 3 players first before I tell you what I tell you now. We should probably have a variable somewhere that says player count, and we put this to 2. And this we're going to use here as well, because we also want to see who plays first, and for that we would do random 1 to player count, and this will give you player. Okay, we didn't execute this one, so we should execute this here. And now this will give us, okay, in this case player 2 goes first. Next time player 1 goes first. Next time player 2 goes first. So we decide who plays first. Player 2 would go first, so that's easy. So let's go first player is player count. And so what have we done so far? We have set up 2 players called Alice and Bob who haven't won yet. The game has not ended yet. We've said that we want to use 2 players, which is interesting because here we have already defined 2 players. We have defined a structure of a car. We have created a list of 4 cards for our cars, and we give some feedback, so we see how many cars are available, and we then assign the cards to the individual players. And now we have 2 decks, decks 1, and we have decks 2, and these should play against each other. So the next step will be picking cards and then deciding how to play these cards, and then evaluate these things and comparing them and defining the winner and running this all over again. But do not overwhelm you. This is the first session of our cards game, and I'll see you in the next video.